All right, guys. Hello, welcome to the next class. We are running apparently rather behind with everything. And for some material, of course, you can see the lecture videos or the lecture notes. All those lecture notes you should know before the final, which happens on the 15th of December. Too quick, too soon. So derivatives of inverse trig functions. So first question is very quickly, is sine of x invertible? Now you can see that in general sine does not pass the horizontal line test, which means that there are several inputs on the x-axis that are mapped to the same y. In other words, sine in general is not invertible. However, if you take a strip of sine, let's say if you take the strip from minus pi over 2 to pi over 2, the curve is passing the horizontal line test and is therefore invertible. So I call this, when I do want to make an emphasis, I call it capital sine x. Capital sine of x is the restricted branch of sine. In other words, it's sine, but where the angle is constrained to be between minus pi over 2 and pi over 2. So in other words, it's constrained in the first and fourth quadrant. You see that? First and fourth quadrant. And I underlined it in red. So that function is invertible, and you can see the inverse graph if you walk on the y-axis, as we talked before. Okay, and the inverse function is called sine inverse y. Now let's see what is sine inverse of 1. Therefore, we are just asking what is the radian angle that will be mapped to the ratio of 1. And you know only one thing can work, correct? And that one thing being, what is sine inverse of 1? It is pi over 2. Clear? Now, what is sine inverse of minus 1? So what angle between minus pi over 2 and pi over 2 included could give you minus 1? Clearly, the answer is minus pi over 2. Yes? Then what's the inverse of, and now very quickly, guys, I mean, you see, a sine inverse of root 2 over 2 is what? Type in the comments. In other words, what's the angle that will be mapped between, angle between pi over 2 and minus pi over 2 that will be mapped where you want it to be mapped? Exactly, Sumaya, pi over 4, beautiful. So it's pi over 4. What sine inverse of minus 1/2, I'm sorry. What sine inverse of minus 1/2? Type in the comments quickly. In other words, what ratio gives us 1/2 but with a negative? And the answer is clearly what? That would be 1/2, and then to get minus 1/2 will be minus pi over 6. Good? Minus pi over 6. Understood? So those are angles that you should know. Good? Now, there is a similar way to deal with cosine, except for cosine, the restriction to make it invertible is from 0 to pi. So if you restrict cosine between 0 and pi, the result is an invertible function. For secant, it is, you see, secant is not defined where cosine is 0. So for secant, the restriction is from 0 to pi over 2 and from pi over 2 to pi. Those you don't have to know as much. But now let's try to find the derivative of sine inverse. We need to know how the derivatives look like. Okay? What's the derivative of sine inverse? And remember, we have a way to deal with inverse functions. The derivative of sine inverse must be obviously related to sine. In the office, if you want to, we will do the geometry, but now let's do the implicit differentiation way of just figuring out the problem. So what's the derivative of sine inverse? All you do is you set y equal to sine inverse, and therefore sine of y equals to x. Good? Sine of y is x. Now the derivative by implicit differentiation is cosine y prime equal to 1, and therefore y prime is equal to 1 over cosine of y. You see, why is it of cosine of y? Because the derivative of sine is cosine. So 1 over cosine y, that relates to, I mean, clearly the derivative of sine inverse is just looking at the derivative of sine, but reciprocal of it. Do you understand why it's cosine y? Yes? It's very natural that it should be so. And it is not the most polite way of leaving the answer. We can write it as 1 over cosine of sine inverse x, because y is sine inverse x. And that can be simplified using the following diagram. Look at the diagram, guys. Here, sine inverse of x means the angle that if sine is applied to it will give you x. It's one thing that will cancel the sine. An angle that if you apply to it will give you x. So any right triangle will do. So one way to get sine of an angle equal to x is to have opposite over hypotenuse equal to x. So I have the Pythagorean, by Pythagorean theorem, I can write x, 1, and on the bottom, root of 1 minus x squared. And therefore, cosine of sine inverse is simply adjacent over hypotenuse.
These are data headers, okay? These are what you'll find in this.
Helen, nice that you joined, but pay attention to this class. Even though we have little time, you understand that if I decide that you are not studying for this class and that you are just copying the solutions of the exam that I grade, I will conduct interrogations, and that will bring nobody any joy. So the answer is cosine of sine inverse of x is root 1 minus x squared. Please confirm in the text whether you understood the calculation. It's very important we move fast. Do you understand? The idea is something that should be obvious to you right away, because we solved such problems again and again. What's the derivative of sine inverse? All you do with implicit differentiation is suppose this is called y. Y is equal to sine inverse. Apply sine to both sides. And what do you get? You get sine of y equal to x. Confirm that you understood those far. And not just understood, you understand? I mean, I think that many of you have this very passive understanding. You should be able to do it on your own without me mentioning it. That's what we are trying to learn in this class. Okay? What does it matter that I say what it is? I mean, I can lie to you, and I do lie. I enjoy lying very much. So the derivative will be what? The derivative of sine y equal to x will be, by implicit differentiation, cosine times y prime equal to 1. And then y prime is equal to 1 over cosine of y. Now, would anybody care to humor me and tell me what's the meaning of this 1 divided by cosine y? Why am I getting cosine? Why am I getting 1 over cosine? Well, yes, I'm solving the equation, but that's not insightful. That's true. But what's the meaning of the 1 over? That's algebra, right? But what's the meaning of it? You understand what's the solve of it, right? So you solved it, sure. You solved you solve for y prime, but what's the meaning of the 1 over cosine? Why is there a cosine, which was to be expected, and why is there 1 over cosine? All right. So meaning is this. You see, I write. Should I give you? Yes, ping, slope, but still, it's kind of the questions are so. What precisely is happening is this. Why is there a cosine? Derivative of sine is cosine, yes? We are just changing perspective. It's really when you view the function, when you change your perspective, you make a y-axis horizontal. The vertical and horizontal are flipped. So really, you are just still taking the derivative of sine inverse. That's what I'm interested in explaining you. The derivative of sine inverse is really not very different from the derivative of sine. The only difference is that my perspective has shifted. You understand that? My perspective has shifted and vertical and horizontal were flipped, right? Sine and inverse sine are very, very similar functions because you might say that they have the same graph. Just change your point of view on the graph and that's the same graph. You understand? So here is basically, maybe you don't understand my questions. Here is how that sounds more or less, right? I show you an upside down person, right? And I ask you, what's the meaning of this person being upside down? You can say change of perspective. I'm just, and you are telling me, well, you move the eyes below the nose. That's the explanation I'm hearing, right? So the explanation that I'm hearing does not make me confident that you recognize that sine inverse and sine can be viewed as very much the same function because they have the same graph. They're not the same function, to be to be blunt, but they are extremely related. The differentiability of one is related to differentiability of the other. You understand? It's basically the difference is between a person standing upright and a person hanging upside down, a trapeze artist of sorts. Do you understand what I'm saying? In your comments, confirm if you do. Right? You're not gonna say, well, you flip the face to the side because that makes the eyes vertical. I don't know, right? The explanation is, do you see that it's the same person? Do you see that sine inverse corresponds to the same graph of sine? And therefore the derivatives are very much related. Just the reason the slope, the reason there is 1 over, it's because it's like instead of dy dx, it's dx over dy. Confirm if you follow. Yes? That's the difference. You understand, guys? The only reason I understand anything slightly better than some of you, it's because of that recognition. It's because I'm just trying to get at the matter. So then what do you have? Then what is 1 over cosine y? If I say y prime is 1 over cosine y, it's just a simple calculation here. Then y is sine inverse. And then I ask myself, what's cosine of sine inverse? Now, I draw myself this right triangle. Here I put sine inverse, and if this is an angle. Sine inverse is always an angle. It's the angle. If you apply sine to that angle, you will get x. That's why I put opposite of the triangle, I put x, and hypotenuse I put 1. Opposite over hypotenuse will be x. Good? Now, the remaining side is hypotenuse squared minus x squared, take root of that. And that's the remaining side by the Pythagorean theorem. And so cosine of sine inverse x can be simplified to root of 1 minus x squared. And so the derivative of sine inverse is 1 over cosine of sine inverse, which is 1 over root of 1 minus x squared. Are you following? Let's see if you are. Your next goal is to find the derivative of cosine inverse. Go ahead, calculate derivative of cosine inverse, please. And do it very fast, guys. I don't have time. All right, good, good. That's good. The minus comes because the derivative of cosine is minus sine. You understand? It is, if you understand those ideas, you are, well, you begin to understand what this thing is about. So again, here is the calculations. When I do implicit differentiation, if I don't know the derivative of something, I can always say y equal to it. Y equal to cosine inverse. And then applying cosine to both sides, I get cosine y equal to x. Right? And then when I take the derivative, this is derivative of cosine is minus sine y times y prime equal to 1. So y prime equals to 1 over minus sine of y, which is minus 1 over sine of cosine inverse. So I draw myself a triangle. Cosine inverse means what? It means apply cosine and you will get adjacent over hypotenuse equal to x. And one way, it's just a proportion. So one way to achieve that is to set adjacent equal to x and hypotenuse equal to 1. You understand? I can make adjacent equal to x squared and the hypotenuse will equal to x. Doesn't matter, right? I mean, they just set it up to one of the triangles and calculate the proportion. So it would be x and hypotenuse is 1 and the remaining side is root of 1 minus x squared. Yes? I don't see your faces, so it's kind of unsettling, of course. I don't know if you understand or not. If you are just talking somewhere with someone on the phone instead of focusing on this class. So the derivative is simply of cosine inverse. It's minus 1 over sine of cosine inverse. And sine will just be root of 1 minus x squared divided by 1. So the answer is minus 1 over root 1 minus x squared. Understood? Now, very quickly, please calculate the derivative of tangent inverse. Okay, good. I see 4 calculations. 5. Good. All right, so the rest of you pace up. Here is what we can do. We can say y equal to tangent inverse. And so if you apply tangent to both sides, you have tangent of y equal to x. The derivative of tangent is secant squared. So we have secant squared y times y prime is equal to 1. And so y prime is 1 over secant squared of y. And that is 1 over secant squared tangent inverse x. For tangent inverse x, to simplify that, you draw yourself this triangle. Tangent inverse, then you put opposite is x, adjacent is 1. Confirm that you understand why you do that. Why do you put opposite x and adjacent 1? In the text, do you understand? Say yes if you do. Tangent inverse, what it means, apply tangent to it and you get x. But if you apply tangent to an angle, it would be opposite of the triangle divided by adjacent. Yes, it would be a slope here. Tangent is a slope. It's rise over run. So x over 1 is the ratio. And then the hypotenuse, just complete the triangle. It will be root of 1 plus x squared. You understand? Hypotenuse is root of 1 plus x squared. Clear? And so secant squared of tangent inverse, secant of tangent inverse is root of 1 plus x squared. Secant is hypotenuse divided by adjacent. Yes? Hypotenuse over adjacent is secant. And if I square it, it will be root of 1 plus x squared squared, which is 1 plus x squared. So secant squared of y can be simplified to 1 plus x squared. We get 1 over 1 plus x squared. It's very simple. Calculate the derivative of secant inverse. And do it very fast. Thank you, Kirill. All right, let's carry out the calculation. Thank you, Lisha. It should take you under 5 minutes to finish the calculation. So what you do is y equal to secant inverse x. Apply secant to both sides. You get secant y equal to x. What's the derivative of secant? It's secant tangent. So y prime is equal to 1 over secant y tangent y. And then I draw myself this triangles. Y is secant inverse. So I have that secant inverse of x. If it's here, then a hypotenuse of the triangle is x, adjacent is 1, and opposite is root of x squared minus 1. Yes? And so apply so then applying secant to secant inverse, I get x, and applying tangent, I get root of x squared minus 1. So the answer is 1 over x root of x squared minus 1. Do you understand? Right? It doesn't matter if you remember it or not. You should have very quick pathways to recall how to take the derivative of secant. If you know how to take derivative of cosine or sine, then secant is 1 over cosine, and you can use quotient rule or something else, or chain rule to figure it out. What particular part? So derivative of secant is secant tangent, and then I just have this triangle, right? So it's the derivative of secant inverse is 1 over secant inverse tangent secant inverse, and I draw the triangle to figure out what would be secant and tangent of secant inverse. So secant inverse of the angle means that apply secant to this angle and you will get x. Now, if you apply secant to an angle, it's always hypotenuse over adjacent. Yes, you understand how I do it? How I create this triangle? Secant applied to the angle will always be opposite over adjacent. But if I apply secant to secant inverse, I get x. They cancel each other. Secant inverse, the minus 1 here means cancel 1 secant. So if I get x, that means that I should get ratio of x over 1. And then completing by Pythagorean theorem, the opposite side is root of x squared minus 1. Yes? You understand it? It's just following instructions, understanding that secant is hypotenuse over adjacent and whatnot. And if you forget the derivative of secant, it's just a derivative of 1 over cosine. So it's always possible to retrieve information, right? So you should try to know the information so that you don't memorize. Now, you should verify that the derivative of cosecant inverse is minus 1 over x root x squared minus 1, and the derivative of cotangent inverse is minus 1 over 1 plus x squared, okay? But the most important ones are cosine inverse, sine inverse, and secant inverse, maybe tangent inverse as well, right? Those two, for the purposes where we'll use them, are less important. All right, so carry out the next calculation very quickly. So carry out calculation A. Find the derivative of tangent inverse squared. Carry out A, please. That's correct, Kirill, very good. All right, so this answer is it's just chain rule, right? You just simply, for A, you take the derivative, it's gonna be 2 tangent inverse x multiplied by the derivative of tangent inverse, which is 1 over 1 plus x squared. We are done, yes? Now, could you please calculate C? The derivative of cotangent inverse t plus cotangent inverse 1 over t. What's the derivative equal to? So we're doing C. Interesting. All right, let's look at it together. So first of all, maybe instead of taking derivatives, we can first try to understand what it might look like. What is cotangent inverse of t and cotangent inverse 1 over t? So let's draw ourselves this right triangle. Cotangent inverse of t means adjacent over opposite equal to t. So that means that I can place this to be t and opposite to be 1. You agree? That's cotangent inverse. Now, what about this angle here? What is that? Well, look at it. If I take for this angle adjacent to opposite, I will get exactly cotangent inverse of 1 over t. Yes? Are you with me? And then what is, and I look at this thing and I ask myself, what is, I just don't calculate like a blind bat. I just ask myself what things are. So cotangent inverse of t plus cotangent inverse of 1 over t, what do you think that number is equal to? What is that equal to? Or ping or pi over 2 to be precise. We don't write solutions in degrees, we write solutions to radians. So it equals to pi over 2. So you are asked to take the derivative of a constant function. So if I take the derivative of it, what do I get? Exactly, 0. And you see, what you do is you always just calculate. Use your brains and think about what is it that you're doing. Understood? Right, the rest you will practice onwards on your own. We are moving on.